Hey guys, it's Mr. Win, and I'm going to go over the exponential review here, the one about writing exponential functions. So I'm going to go over a couple notes page, and then you're going to work on the examples on your own, okay? Now again, this is one of the lessons of 2 that you're supposed to do today, okay? So we're talking about exponential functions. This is the writing portion. You do have a graphing portion, okay? So let's get started with this, writing exponential functions, all right? So when writing, remember your exponential functions and what it means, okay? Exponential functions, that means that your x is going to be an exponent. So whatever your base is, the x is where you have the exponent, right? Your normal equation is usually y equals a times b to the x, all right? You just got to figure out what a is and what b is, okay? A is always your wrote that wrong. Initial value, what you start with. B is usually what you multiply by, your rate. It could be a factor, it could be a percentage. Depends on what it says in our problem, but it's always what you're multiplying by, the rate. Okay, you just need those 2 information. You can write your equation. All right, let's get started. All right, Jenna runs a flower stand. In January, she sold 117 flowers. Since then, sales at her store have increased at a rate of 4.5% per month. Write a function that can be used to determine the monthly sales X months after January. All right, so on the left side, I have the steps. On the right side, we're going to relate it to that example, okay? So step 1, find your initial value. Where did I start with? How many flowers did Jenna start with? Well, here it says, okay, 117 flowers. So that means Jenna initially sold 117 flowers, so A would be 117. All right, and then B, step 2, find B. Is your function increasing or decreasing? So when you have a percentage, you got to figure out if it's increasing or decreasing, okay? And if I read this, it says, since then sales at her store have increased at a rate of 4.5%, okay? So when increasing, you have to do 1 plus. It's adding. When subtracting, it's 1 minus, okay? Think of it as a percentage. It's a part of a whole. 1 would be whole minus your ratio is when decreasing 1 plus that ratio. That's how it increases, okay? Because anytime you multiply by 1, that's the reason why there's no 1 there, it stays the same. So to actually increase, it has to be 1 plus something. But to actually decrease, it has to be 1 minus something. Because again, we're multiplying. Multiplied by 1 stays the same. So it makes sense that above 1, it increases, below 1 decreases. So when you give it a percentage, keep that in mind that you have to do either 1 plus or 1 minus. Okay? So reading this, we know that it's going to increase. Okay, it's increasing. And if I write that as a decimal, that means you got to convert 4.5% into a decimal. That is just going to be 4.5%. Move your decimal over twice. Okay, 0.045 is your rate. And now we're just going to add 1 to that, 1 plus 0.045. So the common ratio would be 1 plus 0.045. And that's easy. It's just 1.045 is your B. Okay? Be careful of that decimal. Plug it into the calculator to check, especially on the STAAR. Check your math. All right? Step 3, just write our equation. So we have the initial A here. Okay? That's going to be 117. And then we have the rate here, B, the common ratio. So that's going to be in parentheses 1.045. All raised to the x. You've got your exponential function. All right? Let's do another example. All right? This is one of those STAAR problems we're going to look at. The amount of lumber in a construction company's warehouse decreases. Sounds important. Excuse me. All right, excuse the bell there. But it decreases at a rate of 5%. Okay, keep that in mind. The amount of lumber was originally 25,600 pounds. Write our function. So step 1, find your A, your initial value, 25,600 pounds. Step 2, find your rate, your ratio, your B. Okay, we know it decreases, so it's always going to be 1 minus, and we know it's at a percentage of 5. Switch that to your decimal, 0.1 move it over twice, 0.05. So your B is going to be 1 minus 0.05, okay? In turn, that becomes 1, actually 0.95. You can plug that in the calculator, check if you wanted, right? Now write your equation. Y equals your A value, in parentheses your B value, raised to the X. So we got Y equals 25,600 times, in parentheses, 0.95 raised to the X. All right? All right, let's look at factors. What if I don't have a percentage? All right, this is using a factor. So right here, same setup, steps on the left, example on the right. A particular type of cell triples. All right, triples. So that sounds important, okay? It's going to triple in number every hour. Write a function that can be used to find the number of cells present at the end of X hours if they are initially 2 of these cells. So say you have bacteria, whatever, there's 2 cells, it triples, it multiplies by 3, you got 6, multiplies by 3, you've got 12, multiplies by, 18, multiply that by 3, so on and so on, okay? So your A, your initial value, what did I start with? Well, there were initially 2 cells, right? So there were 2 cells, that means A is 2. Find B, your common ratio, all right? One thing to remember, if it's increasing, it is always going to be greater than 1. That means you have to multiply a factor greater than 1, right? So that means, like, it has to be above 1, because think of if you multiply by 1, it stays the same, right? So it has to be bigger than 1 to actually increase. If you multiply by a fraction less than 1, right, it has to be, less than 1 to actually decrease, because if it's, at 1, it's going to stay the same. It has to be below it, okay? So that's what it means when increasing, make sure it's above 1. And when it's decreasing, make sure it's less than 1. And here we know it is increasing. It is tripling, right? Triple means you're multiplying it by 3. So your factor is changing by 3, triples, right? Going to write that in parentheses. That means your B is going to be 3. You've got 2 numbers, your A value, which is 2, okay? Your B value, which is 3, put that in parentheses, raised to the X, all right? Okay, moving on. What if I have this example? The value of a new truck decreases by 1/4 every year. It's instead of tripling, it's decreasing by 1/4. The original price of the truck was $30,000. That's the original, right? So we know the A is 30,000. We know that the B is going to be 1/4. And just to make sure, it does decrease, right? It is less than 1, so that is correct, okay? That means our function is going to be Y equals 30,000, factor of 1/4, raised to the X. All right, one last part. What if I give you a table? Okay, from a table, highlighted in red there, you're at 0. Okay, at 0 is always your initial value. So at 0, it doesn't matter if it gives you negatives wherever. At 0 is what is always your initial value. So right here, it says the table shows the population P of frogs. All right, so we're going to try to find out P. Predict how many frogs will be at the pool in the pond at the end of 10 months. So we got to figure out what would it be at 10 months, right? We got a table, but it doesn't quite go to 10, right? So write an equation, and we'll plug in 10. Okay, we'll plug in X for 10. All right. So A, we know your initial value, right? So we know the initial value here is 5, because at 0 it says 5, okay? But B, to get the common ratio, all you have to do is take one number, okay, let's say 135, divided by 45, and that would give you 3, all right? You can really start with 45, divide that with 15, that would be 5. 15 divided by 5 would be 3 as well, okay? So they're all really, you can do anywhere on this table, it should be 3, okay? So that means your factor is going to be 3, and you raise that to the X, all right? But here, since I want to find out after 10 months, I'm going to plug in 10, and if you plug that into the calculator, it would give you 295,245 frogs, all right? All right. Option 2 here is to use technology. This is something you can look at if you like. It's not something I taught you guys, but if you wanted to, here's a step-by-step how to do that, right? You just want to go to list of spreadsheets, put your numbers in, make sure X and Y are labeled, and then do menu for 1A. Okay? And it gives you an A and a B value. You can plug it in. So that's one way to do it too. All right? Let's see example 10 here. All right? Or this example. One thing that is weird here, this should actually be 1 million, okay? So this is going to be 1 million. Keep that in mind, all right? Little typo there. This shouldn't be there. Oops. Let me just erase that. Okay, now that looks like 1 million, right? All right, so that should be 1 million. Okay, so it says find the number of bubbles after 6 seconds. So we're going to be plugging in X for 6, all right? So again, your initial value, where do you start? 1 million. So A is 1 million. How do you get your B? It doesn't matter where. Take 1 divided by the other, okay? So for example, 80,000 divided by 40,000. Again, it doesn't matter where, okay? Use the easiest numbers. That in the calculator will give you 1/5, okay? 1/5, so that's our B value. That means your equation would be 1 million times your factor, which is 1/5, raised to the 6. Plug that all in the calculator. Let's see what that would look like here. So I want to plug that in the calculator. I've got, come on, okay, 1 million times, oops, in parentheses, 1/5 as a fraction. Raise that to the 6. 64 bubbles after 6 seconds. Makes sense, right? You got a ton of bubbles. After time they pop, you end up with 64 bubbles after 6 seconds. Kind of makes sense. One way to check yourselves. All right? So from here, start working on these STAAR problems. These are STAAR problems you've seen on previous STAARs, on the last STAAR even. Okay, so they're going to be recent. That's the notes for that. Be sure to watch the second video over graphing. Make sure you cover both for this class period, all right? Thanks.